Hello everyone, this is Ben Mount, and I wanted to share something with you that I created in Keynote. This image right here was actually taken from Apple Maps, and it's what we're going to be working on. I did not create this image, I simply screenshot it, but I thought I'd start the video off with a pretty picture. But the actual items I'm going to be sharing with you are these right here. We're going to be measuring with vectors today in this lesson, and these shapes right here are shapes that I created in Keynote. That are actually Keynote vector shapes. I have a couple different protractors right here, which I'm gonna tell you about in just a moment. I also have some kind of generic rulers that don't have any units on them, and the reason they don't have any units is so that you can rescale them to match whatever units are on your image or the map or the area that you're working on. Real quick about these rulers, and we will be using both of these in a moment. This ruler right here is it's for the most part solid. I think I have it partially, like maybe 70% transparent, okay? But the words, or I should say the letters on them, are basically cutouts. And so if I move this in front of this white circle right there, you can see that they're basically holes in the ruler, all right? And then this right here, this smaller guy, is essentially the inverse of this one. You probably know that in Keynote, you can take shapes, you can add and subtract out shapes from each other. This has simply been subtracted out from this right here. Now, they're not exactly the same size because I would need to resize them, but both of these are rulers that go from 0 up to 1 and then enable you to resize it for whatever your purpose is. All right. Let me show you this red and white protractor just for a moment. What we're going to be doing is measuring, or I should say really navigating from point to point using vectors. That is something that has a magnitude, or in this case, the magnitude is a distance, and that's what our rulers measure, but also a direction as well. For example, if somebody told you to go, if you went to the middle of town and you asked where the library was, and they said, oh, it's just a half a mile away, that doesn't tell you anything. You need a direction as well, and that's what the protractors do. This protractor right here, as you can see, it's two different colors. It is, as such, it's not a singular Keynote shape, but rather it's two Keynote shapes together. In fact, let me ungroup this for a moment. In order to get those two colors, I'll have to ungroup those, and there we go. So the red kind of crosshair at the 90s and 45s can be separated out from the rest of the white part of the protractor. But that being said, that is one shape, and this is another Keynote shape as well. I simply have these two shapes kind of just glued together, as it were, so they can travel around together, and let's just group those and have different colors for the 90s and 45s. All right. This one, go to my pencil for a moment. It counts from 0 all the way up to 180, and then it continues 190 all the way up to 359, or essentially 360. And that's useful if we're going to be using compass points in the military, as I understand it. The east is going to be 0, north is going to be 90, west is going to be 180, and south is 270. And any place in between is somewhere between 0 and 360. All right. That's one way to measure direction on a coordinate system. This protractor also counts up from 0 to 180 here. Well, I already showed you that, but it also counts from 0 to 180 back to the origin. And so you could use this as a kind of a traditional, you might say, sort of half or semicircle protractor. Most of those count 0 to 180 both ways. Where this is a little bit different as a circular protractor, it also counts from 0 to 180 on the bottom half as well, and that may help with certain applications depending on what your coordinate system is. That being said, I'm going to take this and kind of put it off to the side. Oops, I need to regroup that. Let's select both of these sets of objects right here, and we're going to, all right, sorry about that. They were already grouped. Let's look at this protractor though, and this may not look as interesting because it doesn't have the multicolors, but it is one singular shape. It's all one shape, and if I were to change the color to, I don't know, this right here, the whole thing would change to green. And the good thing about that is it enables you to pick a color for your protractor that contrasts with whatever your background is. And if I copy this and just sort of put it onto here, that would probably not be the best color, right? Because obviously the green would blend into green. But you can change the color to be whatever you want, bright, dark, whatever is the most contrast for you. And what's different about this one, and let's move this kind of off to the side there for a moment. What's different about this is, let's look at it a little more closely. This is what we're going to be using today. It does count from 0. Oops, what am I doing? I'm trying to erase. Sorry about that. It counts from 0 to 180. And yes, it continues 190 all the way through 350. And it counts from 0 back to 180 as well. But for our purposes today, and the purposes that I use in physics, we don't deal with any angles above 90. So this protractor can measure from 0 to 90, all right? 0 to 90 in this quadrant as well. And what's slightly different about this than the other one is the, I guess you call quadrant 3, right? 1, 2, 3. Quadrant 3 starts at 0 and counts up to 90. Like so, and quadrant 4 counts from 0 up to 90 as well. In my physics classes, like I said, we don't deal with any values higher than 90 degrees. And so each one of these quadrants having their own scale of 90 is going to be very helpful for us to measure and then add together these various vectors so that we can find a location on a map. All right, so this is the one that I'm going to use. I'm going to use this protractor right here. Both of them are going to be made available along with this video. But I'm just going to take this and copy it. And we're going to paste it back in here. All right, now again, that's probably the worst possible color I could pick, right? So let's find something a little more contrasty. Red is pretty good. What about blue? White, oh, white looks great. White looks good. Okay, lots of contrast right here. And we're going to use this protractor, and we're going to use one of these rulers. I'm going to take this blue one right here. Copy. Paste that in as well. And that needs a little bit of contrast too. Let's make that white and just kind of cut the... You know what? I'm going to make it black, I think. And... we're going to cut the opacity a little bit so it's kind of like smoky. Kind of like, we'll go to 60% opacity. There we go. All right. And what's good about this being able to resize our rulers and the rulers having no units on them is that we can match these rulers up with whatever scale is on our image. Up here in the very upper right, upper left, is the scale for, I wonder why that won't center correctly. Up here. Up here. There we go. Is the scale for the image. And it says that distance right there is 15 meters. All right. So what I'm going to do is I'm going to take my ruler and I'm going to match it up with that. Put that at the 0, and then I'm going to resize it so that the 15... or the 0.15 is basically where the 15 is right there. All right, and so that's 0, a little bit smaller. That looks pretty good, all right? So even though the ruler only goes up to 1, if we match the 15 with the 0.15, we can conclude that, all right, well, that's not 0.15, but it's actually 15 right there, or that is to say, our ruler of 1 really represents a ruler of 100 meters. All right, and now it's to scale, and we can use it to measure distances on our map. All right. So what we want to do is we want to find, we want to measure some vectors from home plate right here. And of course, this is a baseball diamond, and I'm going to go to a red right here. Let's just hit home plate. home plate is right about there. You can sort of see the base lines kind of coming down to home plate like that. And we want to measure the magnitude, that is the distance and direction to one of these sprinklers. Now, if you look in the outfield, they're probably not super easy to see. But all these little circles are sprinklers. There's one, there's one, there's one, and so forth, all right? And I believe it is this sprinkler right here that's broken. It shoots out water, but just sort of gurgles out and doesn't really spray or anything, all right? And I just picked that one because, well, that's the broken one, as I recall, at least in recent memory. I'm going to measure the vector distance from home plate to this sprinkler right here. But we're not going to measure it directly. We're going to measure it by way of two other sprinklers. That is to say, we're going to be adding vectors together and measuring the magnitude and measuring the direction of each one, so that added together, it will get us from a home plate to that sprinkler right there, but not directly. In other words, think of it like this. We've all heard of pirate maps, right? You get the map, and then it says walk 6 paces east, and then walk 10 paces south, or so on and so forth. That's really what we're going to be doing. But instead of paces, we're going to be dealing with meters. And instead of simply east and south, we're going to be dealing with these compass points from 0 to 90 all around a protractor. Okay. So as it were, we would go from home plate to maybe this sprinkler, and then to that sprinkler there, and then to that one. So our challenge here is to have 3 different vectors, that is to have 2 other stopping points between our origin, home plate, and our destination, the broken sprinkler right here. And we want to measure the magnitude, that is the length, and the direction, or that is the angle each of these is on a protractor, and record them so that we can add them together a little bit later on. Okay. So let's pick a couple different sprinklers that we want to measure to. I'm going to erase all these right here. Let's go from, let's see, it's going to be our first one, how about here? So that'll be 1. And then this guy here will be 2. And then our third one is going to be 3. All right. So I'm just going to call this vector 1 and vector 2 and vector 3, and move these up a little bit. All right. And like I said before, each of these is going to have a magnitude, that is a length, and they're going to have a certain direction, both of which we can now measure with these Keynote shapes that I created. All right. So starting from home plate, what we're going to do is we're going to put the center, that is the origin of the protractor, right at home plate right there. All right. Right in the very center. If I can grab there it is. Okay. There's home plate. And so if right here, if that is our first destination, that means we're going to be dealing in quadrant 4 right there. All right. We're going to be drawing a line basically right to that sprinkler, and then on to the next one. Okay. So can I undo? There we go. All right. So we've got our protractor all laid out. We've got the center at our origin. Now let's take our ruler. And remember, it's now calibrated to match our 15-meter scale at the top, right? And I'm going to turn it. I'm going to rotate it with 2 fingers using, I'm on my iPad right here. And I'm going to put 0 at the origin right there. All right, so that's 0 meters from the origin. And I want this ruler to basically draw a straight line to my sprinkler head. Now I'm off a little bit, so I got to tilt it some more. All right, 2 fingers. And just like we'd be doing this with an actual ruler, we'd be kind of adjusting it back and forth. Maybe kind of like that. All right. And so we have our first vector. We have a magnitude. That is, we've got a length, a distance. So we've got 0, 5, 10, 15, 20, 25, 30, 40, 50, 51, 52, 53. So this is going to be 53 meters from a home plate. And the question is, what's the direction? Now, remember I said before, what we're going to be using this protractor for is to measure in quadrants. And you'll notice that all the quadrants count from 0 to 90 from the horizontal. That is, the horizontal is considered 0, and 90 is the vertical right here. So that means if I'm in this quadrant, and this, I should say this, this line is kind of our 0 line, all right? Then that means that this is our angle that our vector is at. All right, so it's 53 degrees. At what angle is that? Well, it's 0, 10, 20, 30, 40, 50, 60, 70, 75, 76, 77. I want to say 78. This is going to be 78 degrees. But 78 degrees what? Because we've got 4 quadrants. I got 78 degrees somewhere up here, 78 degrees somewhere up here, and somewhere down here as well. 78 degrees, I'm going to say south of east. South of east. Remember, that's east, that's north, that's west, and that's south. And so directly southeast would be kind of that direction right there. Well, it's a little more south than perfectly southeast, but it's south of east. That is, we're starting at 0, considering east-west to be our 0 line. And we're going 78 degrees south of it. All right. Just to kind of complete the analogy, this would be north of east. This would be north of west, and you probably figured out this is going to be south of west as well. So these 4 different quadrants deal with east and west, that is being on the horizontal, and north and south being on the vertical. It's going to be either north of east, north of west, south of west. But just for simplicity's sake right now, we're going to just erase all the rest of them right there. I'll put the south back in. Let's say this is 78 degrees south of east, and this is going to be our very first vector. Right there at the top. And that's going to be, how many meters? It was 53 meters at, so that's our magnitude, that's our distance, 73 degrees south of east. Let's change that to a different color because that's not popping very well. Let's make that yellow. It's a little better. Blue, green, no, that's not good. Yellow pops pretty well, at least on that dark green background. All right, that's our first vector. All right, now we want to go from there. So we've gone here down to our first sprinkler head. Now we want to go to this sprinkler head and then on to our last one right there. All right, so now what we do is we start a new coordinate system because we've gotten from the origin. Let's go a different color here. We've gotten from the origin to our first sprinkler head, and now we are right here. We're starting right there. That's our new origin, and so we're going to move our protractor to this new origin point right here. All right, so right about there. Now that also means, as I go to my eraser here, that I need to change around my ruler as well, because I want to go from this point now to my second sprinkler head. So I'll start that there. We'll see how matched up we are. Nope, I need to tilt it a little bit more. All right, maybe something like that. Again, just using my 2 fingers to tilt and move the ruler. And let's back that out a little bit more. A little bit more of a tilt. It's a little, there we go. Okay. Something like that. And so now I've got a new magnitude and I've got a new direction. In fact, let me move these, this this first vector. I'm trying to get too tricky right here. Oh my goodness, I'm messing it all up. There we go. 73 degrees south of east. Our second vector I'm going to write in yellow as well, so I'll just delete those right there. So vector 2, what's our magnitude? What's the distance that this vector is? We've got 45, 50, 51, 52, I want to say. About the same magnitude, but the same distance, just a little bit shorter as the previous one. 52 meters. Let's get rid of some of these other south, east, west, and north as well. But what's our direction? Well, we can see we're no longer south of east anymore, but rather it looks like we are north of west. Remember, this is west and this is north, and so we're in that quadrant right there. And so we're going now that direction. What is that direction? How many degrees north of west? So it's 10, 20, 30, 31, 32, we'll say. All right. At 32 degrees north of west. That's N-O-W, north of west is what that means right there. Okay. And so that's our second sprinkler head. All right. Let's just move a little bit faster now. Get this last one in. We're going to move our protractor to our new origin now, where our second sprinkler head is. And I was going to erase that, but I'll just keep it there for now. And I'm going to move my ruler around. I need to be careful not to resize my ruler because I sized it for this image right here. But let's kind of do this. All right, I'm going to try to get my 0 at the origin right there, and I need to tilt it a little bit more. Sometimes it tries to snap to a certain direction. I think it's pretty good right there. All right, right in the very center of that circle is my third sprinkler head. And so what's our magnitude? Now keep in mind that we've got to, the direction we're going now, as I erase some of this old stuff, the direction we're going now is this way, like that, to our third sprinkler head. Our magnitude appears to be 20, 30, not quite 35, so 30, 31, 32 as well. Oh, I'm sorry, not 32. It's 32 meters. So vector 3 is going to be 32 meters. I thought 32 sounded familiar. The 32 was the direction of the last one. What's the direction here? So we got a magnitude, that is a distance of 32 meters. What is our direction? Now it's keep in mind this edge of the ruler is really the direction line. But since it's in this quadrant right here, it's going to be, we've got west here, we've got south. It's going to be south of west, right? And so here's where west starts, 0, 10, 20, 30, 40, 50, 60, 70, 80, right about there. What do we have, 80? Like between 84 and 85. I'm going to round it up to 85. All right, and that's going to be, 85 degrees south of west. And that's going to be our third direction at 85 degrees south of west. So what should be true is that we should be able to add now all three of these vectors together, or that is, if you were to go here in real life, you should be able to mark off from the from home plate to our first sprinkler. I think it was that one, and then from the first sprinkler, our second sprinkler over here to that one. Oops, so this one, and then our third sprinkler, that right there. All right, and these are all vectors with magnitudes and direction. We can measure these now using this protractor. Well, come on now, there we go. And this ruler, which can be resized. We've done that using an Apple Maps image, using the scale that is on Apple Maps right there. I'm going to save it for another video to show, if you're interested, how to add vectors together to find out, all right, well, what if I wanted to go right from home plate right to the faulty sprinkler? What would that be? We're going to do that in the next video. But for now, if you simply want to be able to navigate around a location or an area and go from location to location to location, we can do that now with this ruler and with this protractor, which I created in Keynote shapes. I hope that helps. Hopefully you can find some good applications for this, and I look forward to seeing how you use it in the future. Thanks so much for following along. I'll see you on the next one. Bye-bye.